Satbayev University is one of the oldest educational institutions in the Republic of Kazakhstan, the flagship of engineering education of the Republic. History of university inextricably linked with history and culture of our country and its higher education system. As part of the transformation of higher education in Kazakhstan in 2014, the university named after K.I. Satbayev was awarded category National Research University, which made it possible to work with outstanding scientists of the world. The university was founded in 1935 as the Kazakh Mining and Metallurgical Institute. There was two specialties such as geology and exploration of mineral deposits and hydrogeology and engineering geology. First director of the institute was Asir Burkitbayev. The institute played an important role in the formation and development of scientific and practical activities in the field of geology, mining, metallurgy in Kazakhstan. The scientific school, which formed on the basis of the institute, made a great contribution to the development of the ore raw material base of the Republic and the organization of new technologies for mining and metallurgical production. The university has become a base for providing engineering personnel for the industry of the Republic and one of the main sources of personnel for scientific, state and public figures of Kazakhstan. Its history is associated with the names of such well-known scientists and cultural figures as Elmirkhan Baikonurov, Kanish Satbayev, Elias Essen Berlin, Shakhmahadan Yesenov, Akshan El-Mashanid. Accommodation K.I. Satbayev played a huge role in the formation and development of Kazakh Mining Metallurgical Institute. In 1960, Kazakh Mining and Metallurgical Institute was renamed Kazakh Polytechnic Institute. In January 1980, the Architectural and Construction Institute was opened in Alma-Ata, which was a base of the architectural and civil engineering faculties, as well as the Alma-Ata branch of the All-Union Correspondence Civil Engineering Institute. January 1994, Kazakh Mining and Metallurgical Institute converted to Kazakh National Technical University, which was entrusted with the functions of training personnel for the country according to a multi-level structure adopted in world practice, as well as the development of curricula and training programs in technical specialties. In 1999, the university was named after Akademician Kanish Satbayev. Nowadays, Satbayev University includes 9 scientific and educational institutes and 6 scientific institutes, a rich scientific and educational infrastructure, scientific laboratories, and 2 training grounds. The model of a research university adopted in 2015 by Satbayev University implies the creation of a research center, the largest in Central Asia. The high quality of teaching and work of the oldest technical university in Kazakhstan is confirmed by annual awards and high places in international rankings. The implementation of the principle of learning through scientific research is the main task of Satbayev University. The university conducts extensive scientific works, monitoring and analysis of domestic and world trends in the development of science in the profile scientific areas of the university, searches for sources of funding for fundamental and applied research in specialized scientific and educational areas. Satbayev University conducts contract research with well-known private state-owned enterprises such as Kaz Inc., Kazakh Copper, Kaz Chrome, Almaty Heavy Engineering Plant, Eurasian Machinery, Petro-Kazakhstan Kumcoal Resources, Kaz Atomprom, Kaz Ferrostal, Volkov Geologica, Pavlodar Petrochemical, and more. On the basis of the Institute of Digital Engineering and Technology, the university conducts active research in the field of artificial intelligence for the largest industrial enterprises in Kazakhstan and Russia. The university has a rich infrastructure, scientific and research and production laboratories, training centers, and practice bases. The Scientific Library of Satbayev University is one of the most important departments of the university. It is an information resource based on educational, methodological and scientific process to prepare scientific and technical staff. The library infrastructure consists of 8 subscriptions and 6 reading rooms equipped with 140 internet-connected computers and a Wi-Fi zone for working with electronic educational resources. Printed documents provided in a stationary mode, electronic information resources, and online services made for students and teaching staff to realize the goals of the educational programs. The availability of resources is provided by the electronic catalog remotely. The electronic catalog, EC, of the library operates on the base of automatic integrated library system, Mega Pro, and it is always available. The volume of electronic catalog is 174,000 records. Students have access to the services of searching, ordering, booking, reading, viewing of literature. The services are presented in the personal account, both on a regular computer and on mobile devices. The library has a wide resource of specialized educational, methodological, and scientific literature, which is constantly updated. The library fund is completed according to the profile of the university on the basis of curricula and educational programs, applications of departments, or the necessary literature. The total fund of the library is about 2 million copies of printed editions, including more than 30,000 electronic resources. To realize own educational programs, the university provides access to students on educational and scientific literature using an annual subscription to electronic collections. The subscription repertoire includes the following resources: ELS Land Collection, Engineering and Technical Sciences, ELS Collections, IPR Books, Basic Collection Premium, Scientific Journals of the publishing house Wiley Springer eBooks. Permanent access is provided to thematic electronic collections, eBooks, EBSCO, and Elsevier. Students get remote access to the educational resources of Kazakhstan universities on the portal RIEL and KazNel. Also, regular access of users of the scientific library to scientific and technical information and patent services of the RSTL and other university libraries of the Republic of Kazakhstan is provided. The electronic library of the university meets the needs of students and teaching staff for the necessary information and educational resources. The content of the electronic base of the university is formed according to the directions of educational programs and has about 17,000 titles of documents. Many textbooks on specialized disciplines in the state language were developed by KAZ and RTU scientists and are widely demanded by students. Awareness of students and researchers in the field of the latest world scientific achievements and publication activity of scientists is achieved due to access to foreign scientometric databases included in the national subscription. Access to upload scientific information for users is guaranteed by periodical subscription, which is organized by the university. The annual subscription consists of 80 titles of printed publications. In order to support readers, seminars, trainings, consultations on teaching, how to work with subscription resources, scientometric databases, services for authors, bibliographic managers are held. The library's page publishes materials on scientometric instruments for working with databases, WOS, Scopus, Russian Science, Citation Index, etc. Regular information about the resources and services of the library has been established through various communication channels. As part of the policy of academic honesty, the university carries out an examination of works for plagiarism. The library is responsible for the general administration of the system, issuing codes, accounting for checked works and issued codes, examination of teaching staff work, etc. Operators at departments check the work of students for plagiarism. The Institute of Power Engineering and Mechanical Engineering has a recreation room for employees. The interior of the room is designed by the staff of the Institute. This room is designed for seminars, conferences, and most importantly, for the rest of the faculty of the Institute. The recreation room is divided into 4 zones, such as kitchen zone, sports zone, conference zone, recreation zone. Each zone is equipped with all modern equipment and appliances. For example, in the kitchen zone, there is such equipment as a coffee machine, a refrigerator, etc. At the conference area has tables, a projector, a touch TV, and this room also has a tennis table, a sofa, and armchairs. The university cooperates with large industrial enterprises on the basis of which professional practice is conducted for students of Satbayev University. Professional practice is the practical development of professional skills in production in accordance with the requirements of the educational program. Practice is an obligatory component of all groups of educational programs. Professional practice at a university is a type of educational activity aimed at developing professional skills and competencies in the process of performing certain types of work related to future professional activities. The main types of professional practice for undergraduate students are educational and industrial, and for undergraduates, research practice. Educational practice is designed to get acquainted with the specifics of future professional activities, acquire skills in solving practical professional problems. The industrial practice has the goals of obtaining skills in the practical use of theoretical professional knowledge obtained, training skills of solving practical and managerial problems at a particular enterprise or organization corresponding to the profile of the educational program. Each type of practice has goals, specific tasks, and a program, based on which the corresponding base of professional practice is determined. Industrial practice of students is carried out on the basis of the department and enterprises, organizations, and institutions with which there are agreements on cooperation. JSC Almaty, Heavy Machine Building Plant, JSC National Atomic Company, Kazatomprom, Donskoy Ore Mining, Processing Plant Corporation, Kazmus, LLP, Pavlodar Aluminum Smelter Kazkrom, JSC, Kazferrostal LLP, Eurasian Machinery LLP, Kazzinc LLP, Almaty Metrokolus JSC, Maiken Zoloto JSC, Borosan Makina JSC, Volkov Geologia JSC, Kazmunai Gas JSC, Ozin Munai Gas Bormash LLP, Karachakanak Petroleum Operating LLP, Kazflag Gazmash JSC, etc. There is a training ground in the city of Kopchagai for passing field practices, which has all the infrastructure for training, accommodation, food, cultural entertainment for trainees, and Mining Meteorological Institute's training ground. Professors, associate professors, experienced teachers who are well aware of the specifics of the profession and the activities of practice bases are appointed from the university as practice leaders. A mentor from an enterprise institution organization must be an expert in their subject area, have a high level of professional training, developed communication skill and flexibility in communication, stable resulting work, rich production experience, ability, and willingness to share professional experience. Based on the results of each type of practice, submit a report to the department, which is checked by the head of the practice, defended before the commission created by the order of the head of the department. According to the results of the defense, the report of professional practice, bachelors are given a credit and undergraduates a differentiated assessment. For development of dual training on the basis of enterprises, agreements were signed on opening a branch of Cas Ferristal LLP, where the following activities will be held: laboratory classes for students, joint research work, conducting educational and industrial practices, refresher courses for teachers of the department. Good afternoon. I, Maksat Kanabayev, am a cooperative director of the Almaty Heavy Machine Plant. And I would like to note that this year, the oldest enterprise turns 80 years old. Today, the Almaty Heavy Machine Plant is an enterprise with a rich history. It is engaged in the production of various technological equipment for the mining, metallurgical, oil and gas industry of Kazakhstan, and also works with many foreign enterprises of metallurgical, oil and gas and mining industries. I would like to make special mention of graduates of Satbayev University, including myself and many of my colleagues who are now successfully working in various structural units, technical production and service departments of our company. I myself am a graduate of Satbayev University and have been working in this company for 22 years. I graduated from the Department of Metallurgical Machines and Equipment. Now it is called Technological Machines and Transport. The knowledge we gained at the university we use at the workplace. Many professionals who have graduated from Satbayev University work worthy and are professionals in their field. Thanks to them, today the enterprise successfully works and develops. Undergraduates of educational program, operation and service engineering and equipment, and graduate students of educational program, digital engineering of machines and equipment of Institute of Power Engineering and Machine Building continue their educational and industrial practice. The graduates get employed and work as engineers and specialists in production at the industrial areas. I am the commercial director of Almaty Heavy Engineering Plant, which would like to express special thanks to the management of the university and all university professors and teachers who today continue to train personnel and provide us with labor resources As well, in turn, we support and keep supporting Satbayev University, and we will always be glad to see graduates at work and in practice. And I want to say thanks to the university. I, Yermek Tulimesov, am head of the control service of Almaty Heavy Machinery Plant. The plant has a powerful production base. We have our own engineering centers, chief designers department, chief metallurgist, and technologist department, according to the technical specifications of customers designed and all the necessary documentation for the production of products and developed. The plant has a complete production cycle from billets to finished products. After receiving iron and steel scrap, we remelt and receive castings weighing up to 7 to 10 tons. After that, billets are processed in the forging shop and subjected to machining, then undergo heat treatment. This section is the final assembly shop. This is where all the parts and units are assembled. Our products are intended for the metallurgical, oil mining, and energy industries. In addition, there are consumer goods. Our customers are enterprises of Kazakhstan, but we also work with enterprises of CIS countries. These are large-scale enterprises of Russia and Ukraine. I would also like to note that we cooperate with Satbayev University for several decades. Every year, students of educational program of this university undergo industrial practice. Plant specialists share all their experience, also graduate students of education program. Digital engineering and machinery equipment of Institute of Power Engineering and Mechanical Engineering do an internship at the plant. I would like to note that we are very pleased to cooperate with Satbayev University and are ready to work in further joint training of specialists. Research work of the Department of Technological Machines and Transports by Associate Professor Karmanov TD and Kalayev BZ were conducted in the direction of new methods of drilling technological wells for extracting the uranium ores. We have developed a new technology and technical equipment for operating the ore zone. With the help of this technology and technical equipment, greater productivity is achieved during technological wells developed, and an increase in technological and technical equipment for opening the ore zone of uranium ores reduces the number of repair and restoration works at mines by half, thereby bringing multi-billion-dollar savings to mining companies, according to JSS Kazatomprom. Production tests of the proposed scientific work were carried out within the framework of production of technology equipment and equipment for the drilling method, while preserving the original filtration properties of the ore-bearing horizon project. To develop the project, a four-party agreement was concluded between JSC Volkov Geology, JSC Science Foundation, KAZ NRTU, named after K.I. Satbayev, and LLP Innovation DP. Under the terms of the agreement, JSC Volkov Geology participates in implementation of these works as private partner, with obligations to co-finance 25% of the volume of the given works. The total amount of project financing is 116 million tenge. In project course, 3 patents were obtained. At this time, a set of equipment is being sold by JSC Volkov Geology. In the future, we are developing new technologies for the disposal of the used flushing agent and for restoring the integrity of technological wells, casing strings. JSC Volkov Geology drilling companies are in general in need of solving these problems. Preliminary positive decisions on patents have been attained for the given works. Good afternoon, my name is Sirjan. I am an engineer of General Physics Department. I teach practical works on all levels of physics, discipline laboratory classes, and practical classes refer to the main types of educational classes and constitute an important part of theoretical, professional, and practical training. Laboratory classes as a type of studies session should be carried out in specially equipped educational laboratories. Our department laboratories are equipped with all the necessary laboratory equipment, enable our students to understand complex physical processes by doing laboratory work with their own hands. Our labs are equipped with equipment such as Atwood machine, with which we obtain an experimental value of the acceleration of gravity and readings of Newton's second law, installation of elastic and inelastic collision balls, the law of conservation of momentum, studying the phenomenon of impact and the laws of conservation of momentum and energy on the example of a ball collision, study of the law of dynamics of rotational movement using an Ober-Beck's pendulum to obtain experimental dependencies of angular acceleration on the momentum of force and to determine the amount of inertia of the pendulum by the dynamic method, determination of the moment of inertia of a disk, verification of the Steiner theorem, determination of the moment of inertia of the disk by the calculation and experimental methods, determination of the acceleration of the free fall by means of mathematical pendulum, study of free harmonic oscillations, determining of their characteristics, familiarization with one of the ways to determine the acceleration of free fall by means of a mathematical pendulum, determination of the acceleration of the free fall by means of a reversible pendulum, study of harmonic oscillations, definition of their characteristics, familiarization with a reversible physical pendulum, determination of the adiabatic index for air by the Kleemann and Desmoures method, studying of the process occurring in a gas when determining the ratio of heat capacity by the Clement-Desargues method and measuring of the Cp-Cv ratio for air, investigation of electrostatic fields, mastering one of the methods of studying electrostatic fields, determination of the capacitance of a capacitor, studying theoretical methods of calculating the electrical capacitance of simple capacitors, determination of conductor resistance with the help of Winston's of bridge, determining the resistance of a conductor and checking the validity of formulas for series and parallel connections, study of centered optical systems, examination of the laws of geometrical optics using screens with a scale grid, determination of the radius of a curvature of a lens using the phenomenon of interference, study of interference using microlenses, mirrors, and screens with a scale grid, study of light diffraction, a study of diffraction using an alignment module and a screen with a scale grid, object of the study set of diffraction objects, study of dispersion of light, study dispersion and study Brewster's law using collimator and goniometer stage of the telescope, study of polarization of light, study of laws of geometric optics and polarization using a photodetector module. The Department of Descriptive Geometry and Engineering Graphics is part of the Institute of Power Engineering and Mechanical Engineering and trains students in the disciplines of engineering and computer graphics, descriptive geometry, engineering, and machine graphics, general technical academic discipline, the knowledge of which is necessary for engineers of all specialties. Designing construction of engineering objects is understanding the principle of operation of the depicted technical product. Development and application of new technologies are closely related to the images, drawings, pictures, sketches. Engineering graphics should provide future specialists with the skills and abilities to state technical ideas with the help of a drawing. Engineering graphics is the first stage of students' training in design documentation. The main purpose of the discipline is to acquire the knowledge and skills necessary for students to make and read technical drawings, make sketches of parts, and compile design and technical documentation. Students also study the basics of computer-aided design systems, of the graphic part of design documents, CAD, CAM, and CAE systems, using programs for architectural and construction design, Revit, 3ds Max, and mechanical engineering design, AutoCAD, Inventor, Compass, -3D, and SolidWorks. Good afternoon. I, Ainur Kutabayeva. This laboratory is equipped with modern electrical equipment, in particular laboratory stands that allow the production of measurement of optical communication line parameters, study of fiber optic passive components, study of the watt-ampere characteristics of a laser diode and of a light-emitting diode, study of polarization properties of laser and light-emitting diodes, study of pulse modulation processes of a laser diode, modeling of a signal waveform at the receiving end of a real optical communication line, study of linear DC electrical circuits using Ohm's and Kirchhoff's laws, calculation of electrical circuits by the superposition method, study of linear sinusoidal current circuits, study of unbranched and branched sinusoidal current circuits, voltage and current resonance, study of three-phase electric circuits with consumer connection in star, measurement of GFF filter corrector parameters, measurement of optical isolator parameters, measuring of optical splitter parameters, study of EDFA optical amplifier circuit, determination of optical amplifier gain in wide and narrow wavelength range, study of the effects of backscattering and reflection, study of operation of power stabilization circuit and temperature stabilization circuits of EDFA, a barium-doped fiber amplifier. Hello, welcome to Drilling Laboratory, well, workover, and round-trip operations of the Department of Technological Machine and Transport. In this laboratory, we can see simulators. The simulator is designed to set simulation tasks with characteristics and components describing the three components of the simulation's objects. The three components: drilling installation, which consists of all necessary equipment, drilling instruments, instrument of repair wells, and wells. The scenario determines the moment of the call and the type of emergency. The scenario complied by the instructor as a training task for the students, and they're written how to complete task. Here we can simulate various technological operations of drilling wells during various workovers, etc. Consider the process of drilling a well. The well drilling process consists of three interrelated technological process: bit rotation, feeding it to the bottom, and well flushing. The training task drilling include the following tasks: imitation of drilling, provided practice learning of drilling rig direction in the process of well placement, accident prevention while drilling, providing hands-on training in the recognition and complications and emergencies while drilling, and simulated drilling. Metallographic Complex Laboratory is made for conducting laboratory and practical classes for the bachelor students of educational program. Operational and service engineering is in structural materials of technology and machines equipment. Discipline researches of undergraduates of educational program. Digital engineering of machinery and equipment are also conducted here. The laboratory is equipped with the following equipment. Grinding and polishing machines for force pull is used for preparing the metallographic samples. The machine has built-in water supply system with retractable screens and an electromagnetic valve. Force pull machines are used for grinding, lapping, and polishing by using mechanical, self-adhesive, or magnetic attachment systems for abrasive discs and polishing cloths. To control the speed of the circle, the operating time, the on-off of the water supply, and the machine, a touch panel with a digital display is used. An ergonomic rotary knob for quick parameter setting, and latest parameters are stored in memory. Automatic cleaning and drying of the disc. Samples are prepared on this machine for further study of the metal structure on a microscope. To determine the mechanical characteristics of various materials, universal hardness testers are used for automatic measurements in accordance with hardness measurement standards. Measurements are automated. Digital images obtained by the camera are magnified by the lens and displayed on a large LCD display with an anti-glare coating, which ensures high measurement accuracy. Calculation of hardness units is automatic. The hardness values are displayed. A metallographic microscope is used to study the structure of metals and their alloys. A metallographic microscope is designed to study the internal structure of an object in reflected light. To study the optics, it is necessary to determine the required useful magnification of the microscope beforehand. After the optics are selected and installed on the microscope, a microslift is installed on the instrument's slide table, the illuminator is turned on, and the image is focused. After that, it is necessary to adjust the illuminator and aperture of the microscope. The researcher is looking into the eyepiece all the time. And only after obtaining a high-quality picture using screws, filters, and a diaphragm, they begin to study the subject. The study of the subject begins with a non-etched microplate. Defects are detected on it, various inclusions, and the presence of graphite and cast iron is detected. Then proceed to study the etched part of the microchief. This makes it possible to analyze metals and any alloys. Educational and Scientific Laboratory, Operations of Machines and Automation of Production Complexes was established in 2015 based on State Program for Industrial and Innovative Development of the Republic of Kazakhstan for training the qualified specialists for 6 priority areas in Republic of Kazakhstan industries. The laboratory is designed both for conducting scientific research and for conducting laboratory and practical classes on the cycle of academic disciplines at Technological Machines and Transport Department. Educational and scientific laboratories' main purpose is to study designs and principal operation of modern hydro and pneumatic systems on technological machines and equipment, to study the possibilities of their application at mining and metallurgical and oil and gas production enterprises in Republic of Kazakhstan. The objectives of educational and methodological laboratory of the department are to create conditions for students to consolidate theoretical knowledge on laboratory and experimental stands, in particular in the field of scientific research, the study of accuracy and sensitivity of elements and devices of hydro and pneumatic systems, possibilities of their application in production. In the educational process, studying the technological characteristics of hydro and pneumatic systems, determining the needs for using the automated hydro and pneumatic systems. In production activity, the performance of contractual works with modern equipment use. The main areas of educational and scientific laboratory work are research activities in the field of modern hydro and pneumatic systems of technological complexes, studying the latest designs and technologies and their adaptation to educational process and practical applications in production. Educational and methodological work, development and implementation in practice of training simulation modules, technologies, projects, and other developments. Participation in the training of teachers and third-party users in applying the modern hydraulic and pneumatic actuators, software products and technologies in educational processes. Education of contractual workers in the use of modern hydro and pneumatic equipment and the development of applied computer methodological guidelines. Laboratory stands, instruments, and equipment in the laboratory are used for experimental research and physical processes and technical indicators of hydro and pneumatic drives of technological complexes. Educational and methodological laboratory is the material and technical base for the educational process according to the main educational programs implemented by Technological Machines and Transport Department at Energy and Mechanical Engineering Institute. The material and technical and methodological support of education and scientific laboratory is a complex of specialized hydro and pneumatic equipment, in particular 4 hydraulic drive stands and 2 pneumatic drive stands, liquid thermostat, thermometer, and other devices for studying the density and viscosity of hydraulic fluids. The educational activities of the teaching and methodological laboratory are carried out based on schedule of classes, information, and schedule additional classes, research works, etc., are approved by the Engineering and Mechanical Engineering Institute Director. Once every 5 years, the laboratory is certified with the reissue of technical passport. So in 2019, the Educational and Scientific Laboratory was certified. At each laboratory stand, more than 10 types of laboratory and practical work can be performed, and the installed instrument and equipment allow you to take all the readings of hydraulic and pneumatic equipment in real time, excluding the paper form of recording the examination results. The laboratory is equipped with stands of Festo Company from Germany. All equipment is furnished with necessary methodological and educational literature. Within the framework of educational and scientific laboratory, you can write a term paper or thesis and perform research on household services topics or PhD dissertations. In the laboratory, processing metal by pressure provides laboratory and practical classes for bachelor students of the educational program Operational and Service Engineering in the special disciplines. Also provides research by master's degree students of the educational program Digital Engineering of Machines and Equipment. Depending on the conditions under which metal pressure is processed, it can be cold or hot. The metal processed by pressure, depending on technology, can be used in rolling, forging, pressing, dragging, volumetric stamping, sheet stamping, processing performed by combined methods. The laboratory is furnished with the following equipment. A rolling mill is designed to carry out the process of plastic deformation of metal. Students study the rolling process. Rolling is the pressure treatment of metal work pieces, during which they are affected by rolling rolls. The purpose of such an operation that requires the use of specialized equipment is not only to reduce the geometric parameters of cross-section of the metal part, but also to give it the required configuration. In addition to rolling, students study the pressing process, which is carried out on a hydraulic press. Pressing is a type of pressure treatment in which metal is squeezed out of a closed cavity through a hole in matrix corresponding to cross-section of the press profile. Samples of non-ferrous metals and alloys are prepared in advance for laboratory work. In mechanical workshop, students study fundamentals of locksmith discipline. The workshop has the necessary equipment for carrying out work on machining of materials, the manufacture of prototypes, tooling, development of technological process, and testing and export technologies. The laboratory is equipped with metal cutting machines, the other locksmith instruments. Work of locksmiths usually means processing metals in a cold state, and they perform manual work by using various tools. Locksmiths' work consists of various technological operations such as marking cutting, straightening and bending of metals, cutting metals with a hacksaw and scissors, filing metal, drilling, countersinking and reaming, riveting, scraping, lapping and lapping soldering, tinning, etc. Some of the listed operations should be manufactured in hot conditions of metals, for example, cutting, bending, and most of locksmithing operations can be made by mechanical ways, not only manually. Locksmith work is necessary in all industries, and especially in mechanical engineering, where they are very diverse in both nature and complexity. In any manufacturing or farm where there are machines, mechanisms, devices, and various devices made of metal, the work of a locksmith is required. Research work at TMT department is carried out on a systemic, permanent basis in three main directions: oil machinery and equipment, mining machines, machines and technologies of the metallurgical industry. Let me, the Professor of Technological Machines and Transport Department, Jarabek Sechan, to briefly tell you about the objects carried out and will be realized under my direction supervising Republic of Kazakhstan Oil and Gas Complex. Since 2010, within the framework of the academic contract concluded with Tengiz Chevroil under open storage of sulfur in Tengiz, a contract with a financing volume of $870,000, 113 million tenge, for the period of 2010 to 2014. Within the framework of the project, research work was carried out to develop the technology of sampling sulfur from sulfur maps. On the basis of the department, an installation was created for carrying out experimental work on selecting the sulfur. The studies of regime parameters were carried out and recommendations were made on sampling sulfur from sulfur maps method, as well as state standard of Republic of Kazakhstan TS technical block sulfur. Sampling and preparation of samples was developed, agreed and approved. Also within the framework of Project 3, Measurements and Methods MM3 Standard Sample Certification Methods were developed, coordinated and approved in the system of Republic of Kazakhstan State Standard 2. Patents were obtained, 8 scientific articles were published as well. The equipment involved: chromate mass spectrometer, spectrophotometer, dynamic laser light scattering. In the period of 2015 to 2017, within the framework of the grant financing project, development of new methods of open storage of sulfur to reduce the harmful impact on the environment. With a funding volume of 29 million tenge, research work was carried out to protect the development from harmful effects of sulfur maps of large sizes, 300 to 400 meters, and a height of 12 meters. The idea of the work was to create a polymer coating on sulfur maps, i.e. to create protective film from the effects of solar wind erosion from dissolution under the influence of rain and snow. Laboratory and experimental studies of IPS composition were carried out, while the main equipment was creating the strong, durable, and not expensive coating for sulfur maps. The technology and equipment for coating has also been developed within the project framework. IPC developed by us as a low-cost, manufacturability, high adhesive properties, durability, and strength. 2 patents were obtained, 18 scientific articles were published, 1 in the journals included in the Scopus database. Equipment used POSI, Tector thickness gauge, goniometer, diffractometer, In the period of 2018 to 2021, within the framework of the grant financing project, creation of a new technology for collecting high viscosity oils in barns and bottling sites using ultrasonic devices. With a funding volume of 30.2 million tenge, research work was fulfilled to develop the design of a steam ultrasonic device and technology of its application for collecting high viscosity oils. The idea of the work was to develop a steam ultrasonic device with a jet plane radiator providing intensive liquefaction of highly viscous oil and its pumping. The developed device has an annular slit-shaped nozzle and a jet plate emitter and is characterized by high liquefaction performance of high viscosity oil due to the increased volume of steam supplied through the annular nozzle and the additional plate jet ultrasonic emitter that provides steam jet with additional energy due to plate vibrations. As part of the project, modern Evercam equipment was purchased for high-speed shooting with software for processing results obtained by the speed of the process. Received 1 patent, published 10 scientific articles. Equipment used: camera Evercam, viscometer hydrometer. In the period of 2021 to 2023, within the framework of increasing the service life of pumps of rod well pumping units for oil production, grant financing project with a funding volume of 64.6 million tenge, research work has begun on operating the valve assembly of well rod pumps, SSH. A new design of the valve assembly for pump is proposed, which is protected by a patent and should ensure an increase in the service lives of the pump due to the rotation of the shutoff element of the valve when it is opened. At this stage, analytical studies have been carried out and preparations are underway to create a bench experimental installation. The presented stand is designed for a comprehensive study of operating modes of borehole tandem pumping units. Technological Machines and Transport Department at Kazakh National Research Technical University, named after K.I. Satbayev, has been providing theoretical and experimental studies for a number of years on creating the combined pumping unit by combining an electric centrifugal pump, ECP, with a jet pump, ECP plus CN, which can provide the energy efficiency of the pumping process of productive uranium solutions. As a result of the study, a researching group consisting of employees and undergraduates of the department made an original methodology for computational modeling of the operation modes of a tandem pumping unit in downhole conditions in the productive reserve well pump system, which allows with sufficient accuracy for practical application to determine the rational depth of its immersion under the dynamic fluid level in the well and design parameters of the main elements of the jet pump to ensure optimal operation modes of the C and U. The workability and credibility of jet pump's mathematical model is confirmed by comparing the results of computer modeling with the results of research on the physical model of the jet pump in bench conditions. Based on the provided research, 3 patents of the Republic of Kazakhstan for an invention for new designs of jet pumps were obtained. The results of the theoretical experimental studies have been published in international scientific journals with Quatrial Q2 and Q3, which included the Scopus database and have been reported at international scientific and practical conferences, including those in the far abroad, and seminars of the department. For applying in the educational process when teaching the undergraduate and doctoral students, jet and tandem pumping units textbook has been published. The test bench is currently used by students when conducting practical classes in oil field equipment, hydraulic machines and compressors, INL, pumps, fans, and compressors, specialized disciplines, and dissertation research by master's and doctor's degree students. Of Technological Machines and Transport Department, Bisenov Barzan, to briefly tell you about the work realized and are being carried out under my direct supervision. Within the framework of modernization of mining and metallurgical equipment using innovative materials and drive layouts, GF project research work was carried out to analyze the design and drive layouts of equipment with a heavy rotor. In particular, various variants of pneumatic actuators based on pneumatic cylinders and wedge chamber systems have been developed, which can be used in starting and auxiliary devices of ore grinding units, tubular rotating furnaces, converters, etc. 11 patents have been obtained. 15 scientific articles have been published. To study the effects of starting modes on the current characteristics of drives, a stand was developed based on unit equipped with pneumatic panel in which all flow, pressure, and cyclicity adjustments are provided. Videographic paperless recorder controller is a certified measuring and computing complex with a distributed architecture for management for recording data on the state of equipment, mechanisms, etc., as well as recording, displaying, and archiving all ongoing processes and events. The recorder of electrical processes, measuring the current value of alternating voltage, measuring the current value of alternating current, measuring temperature, receiving data from primary converters with standard current or voltage output, storage of the measured values on an external USB flash drive, followed by analysis using RPM 416 data analysis software. Balance SK2 is a portable device for balancing rocking machines. Balance SK2 is designed to solve one of the important tasks that arise during the operation of rocking machines with deep rod pumps. It allows dynamic balancing of the drive elements to be carried out as accurately as possible thanks to the use of watt metrograms. Also, within the framework of the project, a universal pneumatic module that can be used as a maneuvering winch drive in field conditions powered by a ramp with compressed gas cylinders or a compressor. It can be used at enterprises of the mining and metallurgical cluster using technological machines in the production cycle having piping with technological compressed air. The main task of Military Affairs Institute is the training of reserved officers and sergeants in order to form a military trained reserve, as well as additional recruitment of primary positions of officers and sergeants of Republic of Kazakhstan Armed Forces Training Specialists. Military training of reserved officers is carried out in 17 military accounting specialties. Students of the second and third courses are accepted for training under the Reserve Officers Training Program. Specialists are trained in 4 main areas: combat use of artillery, air defense, automated command and control systems, training of reserved officers. The annual recruitment of students for military training is carried out based on Ministry of Republic of Kazakhstan Defense, taking into account the mobilization needs for armed forces. The military patriotic education of students is aimed at forming high morale, professional combat, and psychological qualities, organization, and discipline necessary to fulfill the constitutional duty to protect the motherland. The tasks of military patriotic education of students are solved in the course of classes and during the time allotted for conducting conversations and curatorial work. Institute education and material base ensures a high-quality conduct of all classes provided for in the curricula and programs, and at the acquisition of team, methodological, and practical skills by students. The greatest attention is paid to practical classes in all military accounting specialties, using educational laboratories, weapons, and military equipment. Satbayev University actively cooperates with the largest industrial organizations of the mining, metallurgy, and oil and gas industries in implementing the research projects and training. One of the key areas of the university's work is project development in green technologies field and the extraction of hydrocarbons from alternative sources. The university includes international and educational and production centers, subsidiaries opened jointly with Kazakhstani and foreign enterprises. Satbayev University is a significant international research university recognized by the international community, which has extensive opportunities for training in demand specialties and meets all international requirements.